right, so in the last video, we got our input mapping context set up, and then we got the code that maps it and binds it all around. There was a lot there and may have kind of lost the thread a little bit, which is fine. Honestly, most of this is going to be copy and pasted between projects because this is the kind of thing where it's Unreal specific, where it is only for just really these versions of Unreal. And eventually this is going to end up changing. They're going to simplify this and make it a little bit easier. And someone argue that might have been better just to set this stuff up in Blueprint, but then we don't get all the control that we really want to get otherwise. What do we do next? Well, we created the variables for us to set the mapping context and then our different actions. We need to actually open up our blueprint or our PlayerBall and then set that up. So I'm going to, what do we call this? It's an input. So we're going to search for input. And here we have the ball mapping context. So set this to IMC PlayerBall. Roll action, set this to the IA roll. Look action, set this to, you guessed it, IA look. Then jump action, set this to IA jump. Compile and save. We should be able to move now, right? Nope. It's because we haven't actually told it to do anything yet. We're almost there. I promise, we're almost there. All right, so inside of Visual Studio, I'm going to go to my playerball.cpp. Actually, no, I'll do playerball.h. We made a function for roll, and we'll get to roll. We'll make the ball move later. I want to go ahead and actually create the other function. So we'll do void look, and you know what? I'm going to copy and paste twice. I want one function for roll, one for look, and one for jump. Just like with roll and earlier, we hover over look and hit the little screwdriver icon, create definition. And then the same thing for jump. Create definition for jump. Save these. Then down where we have the binding for roll, I'm going to copy and paste this whole line of code. 2 more times. We have roll action. This one's going to be look action. And we want to trigger the look function. This one's going to be jump action. And we want this to trigger the jump function. Let's get the look done. Let's get the camera working first before we do roll, because that can be a little more complicated. Let's kind of just make sure we get this wrapped up and make this work. Inside of my look function, I'm going to do something called a const. So the const keyword is used to signify that a variable, object, or function cannot be modified after it's initialized. So once you make your variable or whatever, you can't change it. It helps with data integrity, so you know what the value will be. It makes your code more readable because you will always know what the value for that variable. And it also enables compiler optimizations where you can hard define the size of your variable and you'll know it'll never change. So here's an example, const int max value equals 100. This sets up this variable, so that way max value will always be 100. You can't change it. If you try to change it, it will throw an error because you can't assign to a variable that's const. Now, const will always mean something can't be changed once set up. But that doesn't mean it's always going to do the exact same thing. What it does will depend on how it gets used. It means something different with functions, with pointers and other things. And where you put it with certain things matters. For our purposes though, just know that const means we're setting this value, we're going to assign a value to it, and we can't ever change it. Const f vector 2D. This is saying make a vector. So f vector 2D is a special Unreal struct that holds x, y values. It's 2D, so it only holds x and y. So constant f vector 2D, and we'll call this look vector. It's going to be equal to value dot get caret f vector 2D caret parentheses semicolon. What did we just do? Well, this whole thing is set up where when we get input from the user, this f input action value, that is the actual value that comes in numerically from the keyboard or controller. So you can see as I press a button, the input gets read. And you can see that the numerical value for that button goes from 0 to 1. Controllers with their surface buttons, their face buttons, they're either on or off. They're triggers, they're booleans, on or off. Same goes with all of the face buttons. Values are on or off. The joysticks, however, go from a value from 0 or close to 0 to 1 or -1. You can see that as I press up on the joystick, the axis 3 here goes to 1. That's because of the way the controllers work. It works based off of the position of the bottom of the joystick. As I push the top forward, the bottom moves backwards. And if I go the other way, it goes to -1. If I go to the side, axis 2 in this case, the X and Y goes from -1 over here and +1 over here. So we can have any values in between 0 and 1 and 0 and -1. Now, this number, this numerical value, is what is passed into our input mapping context. Now, depending on the kind of controller you have, your triggers are either going to be buttons, like this one is, or it's either on or off, or you might have a value that's similar to an axis, where it'll be from a value of 0 to 1, or if you press it all the way down, it goes to 1. Though that does depend on the kind of controller you're using. With a mouse and keyboard, your keys work like buttons, so either on or off. But your mouse uses the screen space as a grid, where you get a numerical value and it translates it into something similar to what your left stick would be or your right stick would be, based on your setting, where it'll give you an axis based off the direction that the mouse is moving, mapped to the two-dimensional screen space. So we get something similar to a joystick. With our axes, right, our values are going to be positive or negative, and based on the direction. So we get those values in, they get passed into us, so we can actually work with them. And for our purposes, we just want to pull out the values of X and Y from that input action. For look, we want to set to where our mouse is at. Wherever the mouse is looking, we want the camera to move. So for this, we're going to do something called add controller yaw input. And we're going to pass in look vector.x. Then we'll do add controller pitch input. And we'll do look vector.y. And we'll save this. What we're saying here is get the X value for yaw. So X in this case is actually left and right, while our pitch is going to be up and down. Then we go to Unreal. Let's open up our input mapping context. For the mapping for look, let's get this set up. So for look, we want this to be based on the mouse XY 2D axis. So now that we have that, we need to go to our BP player ball, and then let's go to our camera boom. And here, I want to scroll down to where it says camera settings. We want to use pawn control rotation. Turn that on, compile, and save. Press play. Now wherever I move my mouse, I'm looking, so I can look around. And personally, I don't really like how this works. If I'm moving my mouse up and I look down, and I move my mouse back, I look up. This is inverted, which is fine for like flying controls, but for me, it's a little weird for ground controls. But we can fix that pretty easily. Go to Inputs, IMC PlayerBall, Mapping, and we go to Modifiers. Let's add a modifier for Negate. So this takes whatever value we get from the controller and we negate it. But I only want to negate Y. So this takes a positive value of, let's say, +1, then turns it into -1. And if we have -1, it negates it and makes it +1. So it just inverts it. So it gives us actually a non-inverted kind of movement. So now if I look up, look around, my player ball is there. You can actually see the benefit of using a spring arm. If I look down and move just right here, you can see that the camera is zooming towards the player. That's because it's hitting the ground and moves forward to compensate for that. And now some last minute settings for the camera that we're just going to do now, even though we really can't see the end result of that right away, but let's go and just do them now and we can always tweak them later. So select the camera boom, then scroll down to where you see camera settings and then lag. We want to enable camera lag and enable rotation lag. Set the camera lag speed to 5 and the rotation lag speed, we'll leave that at 10. Compile and save. And now when the camera moves, it has a more kind of natural feel. It doesn't snap right to where it was. It will lag just a little bit. This will become really apparent when we are rolling and moving. That's it for this video. Thanks.